Hello guys, good morning. How are you all? Am I audible? Am I visible? Okay, let me just check. So on the last class we talked about so in the last class we discussed about the dimension analysis. So let's take a couple of classes, then we'll go for assignments. Okay. And during the lectures also we'll be considering some problems. Let me share the link. So in this lecture basically we'll be uploading the lectures, or we'll be taking the lectures in English, explicitly in English. So just a moment guys. So if you did not subscribe the channel, please subscribe it, and we'll try to cover mathematical methods and few other subjects in this channel. Okay. Okay, so now without any further ado, let's start. Now this is one of the very important topic and very easy topic also, will not take much time to cover. So briefly there are a few things. Initially you have to get some idea about some vector identities, then we'll go for some vector related theorems, and mainly problems will come from the vector related theorems. Then we have line integral, surface integral, volume integral. So from these topics questions are highly probable. And guys, if you have not downloaded our Physics Hub application, you can download it from Play Store by searching this Physics Hub, or you can just scan this QR code and you will get this app. Let's talk about vectors. What is vector? What is a vector? When do you call it something a vector? So there are two types of physical quantities: scalar quantities and vector quantities. The quantities which have only magnitude but doesn't have any direction, those are called scalars, and the quantities which have magnitude as well as direction. Okay, so let's start with the definition for the sake of completeness. So physical quantities which has both magnitude and a finite direction are called vectors. So this is the first thing, but being a senior student, you should remember that vectors should follow the vectors law of addition. Okay, this must be followed, then only it will satisfy to be called as vector. The controversial quantity, you see, current has magnitude, but it also has direction, but current is not termed as a vector quantity because it doesn't follow the vector law of addition. So this is very primary thing, and let me show you this one. Look at this one. In this figure you are seeing this. So length of this line basically gives you the magnitude, and direction is direction. So if I am drawing two vectors, let's say this is one vector and I am taking another vector in the same direction. So what is the difference between these two vectors? So although they have same direction, let's say n cap direction, both of them have n cap direction, but the magnitude of this vector is larger than this. So sometimes by the length the magnitude is noted. So this is the basic idea of vectors. Now many primary definitions are there of vectors. We are not going into that. We are directly going into the orthogonal resolution of vectors. How we get the orthogonal resolution of vectors, that is important to know because that is very fundamental, and from that we will extend our discussion later on to different coordinate system. So initially we will stick to the Cartesian coordinate system. So you can give the heading orthogonal resolution of vectors. So we are considering a vector in a three-dimensional Euclidean space. So as usual, normal three-dimensional orthogonal coordinate system. So three axes are drawn in this way: x, y, and z. We are taking this course as if you are starting from very beginning. Okay. So that is why we are covering this simple thing also, although you already know, but keeping in mind that your basic is not so much clear, we are covering this. So this is equally helpful to advanced level students and the beginners also. Mainly we are targeting for the beginners. So this is x axis, this is y axis, and this is z axis. Now how do you draw a vector? Let's say this is the origin. Now we have a vector. We get the vector by joining a line like this. So let's say OP is the vector. So how the resolution will work? Orthogonal resolution means you see its component along x axis, y axis, and z axis, and you see x, y, and z, they all are perpendicular to each other. That is why the meaning orthogonal resolution of vectors. So let's say we are calling this vector to be A. Okay. So any vector A in the 3D right-handed, okay, 3D right-handed rectangular Cartesian coordinate system can be represented as so this vector, you see how we denote OP, initial point, final point. So the OP is a vector which we call vector A. So this will be, you see, if you look at this, how many components it has. If you want to reach to this point P, what we have to do? You have to first go along x axis then you have to go along y-axis like this, then you have to go along z-axis. So this much, the amount you go along x-axis is ax, the amount you go along y-axis is ay, and the amount you go along z-axis is az. Then you finally reach to this point P. You started from O reaching to P via ax, ay, az. So these are the components along x-axis, along y-axis, along z-axis. So we write it in this way: ax I cap, ay j cap plus az k cap, right? Here I, j, k are the unit vectors along x-axis, along y-axis, and along z-axis. I cap, j cap, k cap. So these vectors are also expressed sometimes as x cap, y cap, and z cap. So these are same thing. Okay? Either you write x cap or I cap, j cap or y cap, or z cap or k cap. So they are same thing. And what are these x, ax, ay, and az? These are the rectangular components. Rectangular components of vector A along x, y, and z axis, right? And how do you write the magnitude? You write the magnitude of vector A look, this is very fundamental thing. Once you go to the other coordinate system, the process will be same, the quantities will be different. Just we write it as A mod, so this is equals to root over ax square, whatever be the components, x component square, then ay square, az square root. So this one you need to remember. For complicated expression also, we will be using the same formula to calculate this magnitude of the vector. Now if I want to calculate the unit vector along the direction A, okay, so unit vector along the direction of A is written as A cap. The basic definition, this is vector symbol, this is a unit cap, unit vector direction. So unit vector along A is written as A cap, and A cap is defined in this way: vector A divided by modulus of vector A. So vector A, we have already got it, ax I cap, ay j cap, az k cap, divided by the magnitude. What is the magnitude? Is root over ax square plus ay square plus az square. So this is the magnitude, right? Now a very important term is there, that is called the direction cosine. What about the direction cosine? Direction cosine of vector A. How do we evaluate it? The direction cosine. You can see this vector A is making some angle with x-axis, it is making some angle with y-axis, and it is making some angle with z-axis. So let's denote these angles to be alpha, beta, and gamma. So let's say if A makes an angle of alpha, if A makes angles, the three angles are there, so it will be angles. If A makes angles of alpha, beta, and gamma with x, y, z axis respectively, then the direction cosine of A is given as, how do we write the direction cosine? So you can say Ax is nothing but A cos alpha. We can say Ay, the Ay is this much. So on this axis, if you want to represent, so it is like this. Okay, now it is same. This much portion is nothing but Ay. So Ay is A cos beta, and on the other hand Az, although it is saying this much, so this is equals to this much, right? So this much portion is your Az, and that is why we can write the direction cosines of A is, we write L is equals to cos alpha. This is direction cosine, and what is the value? You see, Ax is equals to A cos alpha. So Ax upon A. A is what? A is the magnitude of the vector A. Similarly, M we write cos beta, that is Ay upon A, and N, this one we write cos gamma, and this is nothing but Az upon A. And these direction cosines L, M, N, these are direction cosines. Direction cosines of vector A. These direction cosines follow this property, and this property you should remember that if you take the square, L square, M square, N square, they will give you 1. This one needs to be remembered. In your numerical question, this formula may be utilized. And you see, we can also express these components Ax, Ay and Az in terms of the direction cosine. So you see, if you write Ax, we can just simply write it La. Okay, now. So if I just express the vector in terms of the direction cosine, how do you write? So if I write A cap, let's say we are writing A cap, so we can write, you see, Ax by A I cap plus Ay by A j cap plus Az by A k cap. So we can we not write it in this way, L I cap plus M j cap plus N k cap. So in this way you can express the unit vector along A in terms of the direction cosines. So this is the concept of direction cosine. I hope you understood. And some fundamental things which you already know, but you should keep in mind. The 3 unit vectors I cap, j cap and k cap. So you will take a cyclic rotation like this, and these unit vectors follow certain properties, like I cap cross I cap if you take, or if you take j cap cross j cap, because these are the same vectors, so angle between them is 0 degree, so the value will be, the cross product value will be 0. And on the other hand, if you take consecutive vectors, I cap you take, then you take j cap, what it will give you? It will give you k cap. J cap and k cap if you take, it will give you I cap, and if you take k cap and I cap, it will give you back j cap. So in this way it works. And one thing we have already discussed, but let me tell you, if you have two vectors, then they will be called collinear. If you have two vectors, they will be called collinear. Collinear means these two vectors are lying on the same line. Let's say I am taking this one vector and this one another vector, and they are lying on the same line. So let's say this is vector A, this is vector B. So two vectors will be collinear. Two vectors A and B will be collinear if you see A and B are along the same direction, so the angle between them will be 0 degree or phi. So two vectors A and B will be collinear if the cross product A cross B, this should be 0, sine 0 is 0. So sometimes question may come based on this formula, so that is why we are giving you this. So the vectors may be parallel or anti-parallel. Okay, how do you determine whether they are parallel or anti-parallel? If you see the two vectors are like this, they are parallel, and if you see these vectors like this, they are anti-parallel. So in both the cases, they are collinear, lying on the same line, but this condition will be satisfied for both of them. Okay, so here angle is 0 degree, here angle is phi. Let's move on. We go to the scalar triple product. So few definitions which you should know, because those things come in your examination. So let's talk about the scalar triple product. Scalar triple product basically the product of three vectors A, B, C, and you see when you take the scalar triple product, you get a scalar. So scalar triple product of three vectors A, B, C is defined as A dot B cross C. And how do you write the value? You write the components of A, that is A1, A2, A3. Then you write the components of B, B1, B2, B3. Then you write the components of C, C1, C2, C3. And you take the determinant, you get the value of the scalar triple product. The scalar triple product is represented by writing the vectors in a third bracket, A, B, C. Right? Now they follow, these scalar triple products follow certain properties which we will talk about now. So you see A dot B cross C, this vector will be same as B dot C cross A. So in each time, if you remember this one, A, B, C. So A dot B cross C, now you take B, so B dot C cross A, now you take C, C dot A cross B. So values will be seen, all these three values. In this notation, how do you write it? You write A, B, C. How do you write it? B, C, A. And how do you express this one? C, A, B. Now the scalar triple product is used to denote the volume of a rectangular parallel pipe tire. Okay. If you know the three sides, and the three sides is designated by the three vectors A, B and C, then the volume of this parallel pipe will be given by the scalar triple product A dot B cross C. So volume of a parallel piped having A, B, C as congruent edges. So you can see A, B, C, they are congruent edges. Then the volume V will be expressed as A dot B cross C. So it is similar to writing this B dot C cross A. Now volume cannot be negative, so we have to keep a mod symbol. So modulus of A dot B cross C. So in your examination, question may come in this way, that you will be given some vectors A, B, C, and you may be asked to find out the volume. So find out the volume enclosed by the vectors, 3 vectors in this way. Then you can have to utilize this scalar triple product. Actually, you have to understand what formula we have to use. If you do not have the concept of these things, then you will not be able to tackle the problems. Now, using scalar triple product, we can also define the coplanarity. Like if you are given 3 vectors, how do you say that whether they are coplanar or not? To check coplanarity, we can use this scalar triple product. So if A, B and C are coplanar vectors, then we can write A dot B cross C equals to B dot C cross A equals to C dot A cross B. This is equals to 0. How do understand this? Let's say we are taking this in this way. Let's say I am giving you 2 vectors. One vector is like this, another vector is like this. Okay, let's say this vector is vector B, this vector is vector C. So obviously the direction of B cross C will be along this. Now if our vector A should also lie on this plane, okay, if our vector A should also lie on this plane, what criteria it will satisfy? So the angle between A and B cross C, you see this B cross C is perpendicular to both B and C. B and C is lying on this plane. So obviously the angle between B cross C and A, this angle will be 90 degree. And if it is 90 degree, and if you take the dot product, cos 90 is 0. That is why this is the condition of coplanarity. I hope you understood. So this is sufficient for the scalar triple product. Let us now go for the vector triple product. These are small thing, but for the sake of completeness we have to cover. Vector triple product. Vector triple product is defined for 3 vectors and ultimately it gives you a vector. So vector triple product of 3 vectors A, B, C is defined as A cross B cross C. So this is the usual formula, back minus cap, B into A dot C minus C times A dot B. So this is the formula we have for vector triple product, and it also follow a property, an important property, A cross B cross C. If you remember this one, then that will be easier for us to write the cyclic thing. A cross B cross C plus B cross C cross A. We have taken this C cross A. Then we will start with C. So C cross what left? A and B. So in this way, if you write, then it will be easier for us to remember. So the product, the sum of these vector table products will be 0. Okay, so the theory part is done. Let us now quickly go to some simple problem so that you understand the thing more clearly. Chalo. Okay, let's go for a problem. For what value of m the three vectors A I cap minus j cap minus 2k cap B is equals to 3 I cap plus 5 j cap plus 6 k cap C is equals to minus I cap plus 4 j cap plus m k cap will be coplanar. So you are given 4 options. Option A 13 by 2, option B 7 by 2, option C 5 by 2, and option D 11 by 2. So how can you solve this particular problem? For what value of m these three vectors will be coplanar? So we have already given you the condition of coplanarity. So if three vectors are coplanar, then their scalar triple product should be 0. Okay na? So if A, B and C are coplanar, then we have A dot B cross C, this is equals to 0. Or you see, how do we write the scalar triple product? We write the components. So component of A is 1 minus 1 minus 2, 1 minus 1 minus 2. Here it is 3 5 6. Here it is minus 1 4 m. This value will be 0. So let's calculate. So we have 5m minus 24 and minus 1 is there, so it becomes plus 1. So 3m plus 6 is minus 2, 12 plus 5, 5m plus 3m 8m, minus 24 plus 6 minus 18 minus 20, okay, minus 18 and minus 34. So हो गया ये 52. If it goes to the right side, then m becomes 52 divided by 8. So 4 13, 13 by 2. Option A is matching. Okay. So in this way you can solve this kind of problem. Let's move on to the next problem. The next problem is looking like this. If any vector, let's say x equals to I cap cross A cross j cap plus j cap cross A cross j cap, इसको I cap करो, प्लस k cap cross A cross k cap, then x can be expressed as options are 0 vector, option B vector A, option C 2A vector, option D none of these. How do you solve this problem? So x is given as I cap cross A cross I cap. So how do you write it? We can utilize the formula of this vector triple product A cross B cross C. This is the vector triple product. So B into A dot C minus C into A dot B. So you can utilize this formula. So x will be, here B is A, you see, if you consider the first one, here B is equals to A, so it becomes A into A dot C means I cap dot I cap minus C is I cap, C into A dot B, I cap dot A. So in a similar manner we can write for J cap. And we can write for K cap as well. Okay, so in this way we can express this. I cap dot I cap, we have already told you what is this value. This is value, this value is 1. Okay, so A minus A dot I cap means the x component of A, so that is AX and this I cap, plus A minus AY J cap plus A minus AZ K cap. So 3 A's are coming, that gives you 3A, and this AX I cap plus AY J cap plus AZ K cap, that is giving you vector A. So 3A minus A is 2A. So option C is the correct option. Okay, let's move on to the 3 things. We'll be talking about gradient, divergence and curl. So first we'll talk about gradient. How do we define the gradient? Gradient is defined for a scalar function. So let's define this. So we are taking it as a detailed course, so we'll be also writing few lines so that you get a complete thing. So gradient of a continuously differentiable scalar function phi of x, y, z is defined as how to define? We define it as grad phi. Grad is an operator. It is written as del x I cap del y j cap del z k cap, and this is phi. So we write it as del phi by del x I cap del phi by del y j cap del phi by del z k cap. So this is the primary definition of the gradient. Here we have this grad, which is called the gradient operator, nabla operator. Del x I cap del y j cap del z k cap. So this is the nabla operator or del operator. This has got various names: del operator or grad operator, or sometimes it is also called nabla operator. Now let's quickly write the physical interpretation as well. This is not important for your NET exam purpose, but may be helpful in interviews. Interpretation, physical interpretation. So if you talk about this grad phi, what does it basically represent? If you consider a scalar surface like this, so let's say this is phi of x, y, z, then grad phi basically represents a vector perpendicular to the surface at some particular point. Means at this particular point, if you draw a tangent like this, then you see this gives you the direction of grad phi, and if you specify some point, then this grad phi is evaluated at this particular point. So what basically it represents, you see del phi by del x, del phi by del y, del phi by del, and this direction is this. So it basically represents the change along the normal direction. Okay. So the magnitude of gradient of phi at any point, let's say P, whose coordinates are x, y and z, is equal to the, you see, del phi by del x. If you have, let's say, del x by del t, what does it mean? It means rate of change of x, time rate of change of x. So in a similar manner, del phi by del x is equal to rate of change of phi with respect to x. So the same kind of thing is applicable here. So the magnitude of gradient of phi at any point P, x, y, z is equal to the rate of change of scalar phi with distance, because as you go along this, so we are basically taking the rate of change along x, along y, along z. So it is basically the distance, right? The rate of change of scalar phi with direction with distance, I told no, with distance along the direction normal to the level surface. So this is the level surface, you can see, and this is the normal. This is the level surface, and the change is happening along the normal direction. This. So this is the physical interpretation of gradient. One other thing you write, note. The direction of grad phi is that along which the rate of change of phi is maximum, and obviously where the rate of change will be maximum, obviously normal direction. You see, if I have a function, I'm giving an example. Let's say the function starts from here. If you follow a path like this, so the rate is not so much. If you take this path, you see the rate of change is higher. If you take this one, it is higher. If you consider like this, here it is like this. So when it will be maximum? When you consider perpendicular, then it will be maximum. So the direction of grad phi is that along which the rate of change of phi is maximum. So I hope you understood. Now here we are using a term called level surface. What is that? What is a level surface? Okay, look at this. This thing I was showing in the picture. This was the phi function, phi of xyz. At any particular point you have taken and you have drawn this tangent plane. Then grad phi basically denotes this. So at each point of the level surface, the value of the scalar function phi of xyz will be same. So you get the direction grad phi. Now if you want to find out the unit vector along this direction, unit vector along the perpendicular direction, how do you express it? You already know it. The vector and its divided by its magnitude. So that will give you the direction, unit vector along the perpendicular direction. See, this is the unit vector along the perpendicular direction. Now let's talk about a directional derivative. It's a simple thing, directional derivative. In alternative language you can understand it is like derivative along some particular direction. Let me give you first an example. Like if you have a vector A, let's say, if you want to find out a component along any arbitrary direction, let's say n cap may be anywhere. How do you calculate the component of A along n cap direction? We take simply the dot product, right? So this is the component of A along n cap direction. This is the straightforward rule. Now directional derivative means you are taking the component of a derivative along some particular direction. Okay, so let's define this. Directional derivative of a, or directional derivative of phi in the direction of a is defined as, so you just simply compare with this. So what thing we are defined? We are defined the derivative of phi. So derivative of phi, it is basically represented by grad phi. Okay? So its component along the direction a. So we will write simply grad phi dot a cap. Okay, na? So this is what directional derivative is. So grad phi and unit vector a is like vector a divided by modulus of vector a. We can also write, look, this modulus of vector a is written in this way also. Just if you keep simple a like this, not bold, then it represents the magnitude of this vector a. Okay. So let us now go for some problem so that you understand it better. Okay, look at this problem. The direction grad f for a scalar field this at the point P112. So simple problem, as you are learning it from the very basic, from the very beginning. So you can give it a try. You have to just find out the direction of grad f. Okay. So first of all, you need to calculate grad f, then you can find out the direction. So what will be the value of grad f? Del f by del x I cap plus del f by del y j cap plus del f by del z k cap. So del f by del x I cap is equals to, you see here x will come, here minus y will come, x minus y I cap plus del f by del y. So minus x is coming, and what about del f by del z? Only z is coming. So you want to find out the direction of grad f, means you have to find out n cap. So what is the value of n cap? That is nothing but grad f divided by modulus of grad f. So this is equals to nothing but x minus y I cap minus x j cap plus z k cap divided by, if you want to take the modulus, I told you, you have to take square of the components and you have to just add them. So x minus y whole square plus x square plus z square. And when you specify the point, means n cap where at 1 1 2, means at x equals to 1, y equals to 1, z is equals to 2, then it becomes how much? This is 0, so this is minus j cap plus 2k cap divided by root over x square plus z square. So 1 square plus 2 square, and this is 0. So minus j plus 2k cap divided by root 5. So option B is matching. Okay, so I hope you understood. So this is a simple problem. Now the problem can be made little bit complicated. How? The process is simple, but the scalar field or the scalar function phi, that may be given little bit complex. So as you can see in the next problem, look at this problem. This becomes little bit complicated, but the process is simple. The unit normal vector, basically it is asking about n cap of the point this 1 by root 3, 1 by root 3, 1 by root 3 on the surface of the ellipsoid. X square by a square plus y square by b square plus z square by c square equals to 1 is. So the process is simple, process is same. Can you do this problem? Guys, you can join the dedicated WhatsApp group for physics of English only. You can join that. It is given in the description. The link is given in the description. So let's try to evaluate it. So first of all, how to determine phi? So whatever expressions you are given, you will take this one on the left side, and the first way, actually this thing you have to find out. It is represented pictorially beautifully. Let's try to evaluate the solution now. So here, what is phi? Phi, you see, x square by a square plus y square by b square plus z square by c square. 1 was on the right side, we are taking it on the left side, so it becomes minus 1. So in this way, phi is defined. Once phi is defined, we can easily calculate n cap, that is grad phi, upon modulus of grad phi. This kind of problem may come in your examination. So first of all, evaluating grad phi is pretty simple. I am not writing all the formula, just you can directly calculate it. Okay. So what will be the value of grad phi? You see, 2x will come from here, and a square is a square, so 2x by a square I cap plus 2y by b square j cap plus 2z by c square k cap. Simple. Now if we calculate the grad phi at the given point, 1 upon root 3, 1 upon root 3, 1 upon root 3. Just put the values. So what do you get? 2 by root 3 a square, 2 by root 3 b square, 2 by root 3 c square. In this way you get. Now if you take the modulus, as I told you, देखो, in the very beginning I gave you the formula how to find out the magnitude. Take the components, square them and add them all. This is what you have to do. 4 by 3a to the power 4, 4 by 3b to the power 4, 4 by 3c to the power. Obviously this is evaluated at this point. One by root 3, 1 by root 3, 1 by root 3. Then we have the mod. So we can take this 4 by root 3, 4 by 3 common, so it will become as 2 by root 3, right? And in the denominator, so under root everything will be there, a to the power 4, b to the power 4, c to the power 4. So this is b to the power 4, c to the power 4 plus a to the power 4, c to the power 4 plus a to the power 4, b to the power 4. This is the thing it will come. So kind of homogeneity is there, so it is easier for us to calculate. And now we can calculate this unit vector by taking the ratio of grad phi and modulus of grad phi. Okay, I am just denoting this as p. Okay, because my writing this multiple times is taking too much time. So it is like grad phi evaluated at p, grad phi evaluated at t magnitude, right? So you see, if you take the ratio, this 2 by root 3, 2 by root 3, it is cancelling, and here it will be a square, b square, c square, and every time you see a square will be cancelled, so b square, c square will remain, b square is cancelled, so a square, c square will remain, c square is cancelled, so a square, b square will remain. So b square, c square I cap plus a square, c square j cap plus a square b square k cap, right, divided by this thing will come in the denominator root over b to the power 4 c to the power 4 a to the power 4 c to the power 4 a to the power 4 b to the power 4. Okay, and this is matching with option D. So this kind of problem may be given to you and you can easily do this. चलो मैं एक प्रॉब्लम दे देता हूँ. Let's give you a problem as homework. In the last class also I gave you one problem as homework. You can join the WhatsApp group, given the link is given in the description, and you can send us the solution. Okay, let's take this problem as homework. So similar problem, I have already solved 2 and it's your turn to solve it at home. So take it as homework, simple problem. The equation of a surface of revolution is z upon root 2 is equals to plus minus root over 3 by 2 x square plus 3 by 2 y square. The unit normal to the surface at the point A is. So exact same problem, only thing is this. So don't get frightened by looking at this expression. What you do, you take square on both sides. So if you take squares on both sides and simplify, then you will get equation. Then you will get an equation. Then you write them at phi is equals to that. So that will be your expression of the scalar function phi. And once you know that, the process is straightforward again. N cap grad phi upon modulus of grad phi. Okay, so we will try at home and you have to find it at, you see, root over 2 by 3 0 2. So you will get option B to be correct. I am giving you the answer key. Option B. So you will try to do it at home. One last thing I would like to do today, then we will wrap up the session. Sorry guys. The next thing which we're going to discuss is a very important thing, that is tangent plane and normal to the level surface. We have discussed it multiple times. Let's discuss one more time because we are doing everything from fresh now. So you can give the heading tangent plane and normal to the level. So this is very easy topic. If we have understood till now whatever we have taught, then understanding this one is like taking water. Chalo. So first of all, level surface, let's draw a level surface. Let's say this is a level surface, right? This level surface is denoted by phi x, y, g is equals to some constant c. Now if I consider a particular point, let's say P, whose coordinate is given as x, y, g, then what is the tangent plane at this? So before going to the tangent plane, we need to understand the tangent line. Okay now, so tangent, this is the tangent line. Tangent plane is like if you just keep many lines one after other, then it will give rise to a plane. What do I mean? If you do it in this way, then this becomes a plane. Okay, so you have to find out the equation of this plane. You consider a bowl and a cardboard is placed on the top of it. Now you have to find out the tangent plane equation. So if you see, if I draw, okay, let's draw it afresh because the picture is not giving us what we are intending to show. So let's first draw. You understood the concept, right? So let us first draw the plane so that it looks like it is a tangent plane. Now let's target to draw the level surface. kind of reverse engineering is happening. Okay, so this is the surface phi of xyz equals to c, and this is the point, let's say p xyz. Now it is, I think, clear. So what if we draw the perpendicular? So if you draw this perpendicular, then what it will give you? It will give you the direction of grad phi, right? Now if I take any point on the plane, this is the plane, this is the tangent plane. What will happen if I take any point? You can take the point here, here, any arbitrary point. So arbitrary point, so arbitrary coordinate will be there, x, y, j. So these are capital, okay, to differentiate it. And if you join these 2 points, so you get a vector, right? Let's say this point is denoted as r. So obviously this PR and this grad phi, they are making an angle 90 degree. So they will satisfy this condition that grad phi dot PR, this should be 0, cos 90 is 0, or the reverse thing is also true. You can also express it in this way. You can express it, let's say PR dot grad phi equals to 0. Now you consider these are the points P and R. So they are denoted with respect to some arbitrary reference point. So let's say the origin is here. Okay. So the position vector of P is this. Position vector of R is this. You can consider it in this way. So this is the position vector. Let's say this is R, small r. Okay. And this is capital R. So what will be this? This will be capital R minus small r. You can use vector law of addition to verify this. You see, if you add r and this, so you get back capital R. And if the coordinates of 2 points are given, we can easily find out the vector, right? So it is nothing but capital R minus small r dot grad phi equals to 0. Now capital R minus small r, how do you calculate? By taking the difference of their coordinates. Okay, I am just writing it, x minus x I cap plus y minus y j cap plus z minus z k cap. This is the vector r minus r dot grad phi. Grad phi you already know, del phi by del x I cap, del phi by del y j cap, del phi by del z k cap, right? Now if you take the dot product, what do you get? You get x minus x del phi by del x plus y minus y del phi by del y. Guys, you can pose your question, okay? Don't just listen. If you have any question, you can ask, or if everything is clear, then that is okay. Actually, these things are very simple. There should not be any question. So this equation basically gives you the equation of the plane. This defines the equation of the tangent plane. So this is the ideal theory. Now in your examination, you may be given the question in different forms. One such question which came in December 2011, we will try to do. Let's go for the problem. Give it a try. The equation of the plane that is tangent to the surface xyz equals to 8 at the point 1, 2, 4 is. Give it a try and let me know the answer. Okay, let's try to evaluate this problem. First of all, the surface is given to be xyg is equals to 8, and the point where you have to find out the tangent, that is 1, 2, 4. Okay, so you can imagine that a tangent plane is there like this. So you can imagine in this way, this is the tangent plane. So you have to find out the equation of this tangent plane. So if I consider this point to be P, this point to be P, and let's say another point is there on the tangent plane, let's call it T, whose coordinate is x, y, z, we do not know. Then you join it, and the perpendicular you already have, that is grad phi. Grad phi evaluated at this 1, 2, 4. So the condition will become grad phi evaluated at 1, 2, 4. So vector dot this TP or PT, whatever you say, will be 0. This is the thing, right? Sorry, first of all, grad phi, what is grad phi? What is phi? First of all, phi is nothing but x, y, g minus 8. So grad phi will become, you see, yz I cap plus zx j cap plus xy k cap, right? This is evaluated at 1, 2, 4 dot TP. TP, as I told you, you have to take the difference in the coordinates. So x minus 1 I cap plus y minus 2 j cap plus z minus 4 k cap. This would be equals to 0. Now put the value of x equals to 1, y is equals to 2 and z is equals to 4. Okay, so yz is 8, right? So 8 I cap plus zx 4 j cap plus xy is 2 k cap multiplied by this one, x minus 1 I cap plus y minus 2 j cap plus z minus 4 k cap. This is equals to 0. And if you take the dot product, what do you get? Let's give second bracket. So 8 times x minus 1 plus 4 times y minus 2 plus 2 times z minus 4, this is equals to 0. Now you take 4 common, so 4 times x minus 1 plus 2 times y minus 2 plus z minus 4. If you simplify it even more, what do you get? You will get 4x plus 2y plus z is equals to minus 4 minus 8 plus 4, so 12, minus 12 plus 12. So 4x plus 2y plus z is equals to 12. So in this way you evaluate the solution. Okay, so I hope you have understood everything. In this lecture we have covered the very fundamental thing of vectors. On the next day we'll try to continue from here, and the next class we'll try to take on Monday 8 p.m. Monday 8 a.m. Okay, Sunday will be off. So see you Monday at 8 a.m. again. And if you have not downloaded our physics application, you can download from the Play Store. The link is given in the description. You can also join Telegram group and WhatsApp group. All the links are given in the description. Okay, so this is all for this video, guys. If you are new to this channel, so please subscribe the channel and don't forget to press the bell icon. Thank you. See you in the next class. Bye bye. Take care.